Hi, welcome to our next lesson. We will be dealing with adding and subtracting polynomials, and the objective is how do we add and subtract polynomials. When it comes to adding polynomials, you're basically combining like terms. That means any exponent, not exponents, same exponents, yeah, and the same base between the variables, and if they have the same exponents, you combine them. So let's look at example number 1. So we have two polynomials that we're adding up, and the best thing to do would be to combine or group the combined like terms. So what I did here, anything that had x squared, I circled it in green. Anything that had x in its as a variable, I put it in red, and any coefficients, that means numbers standing by itself, I made a little bubbly cloud-like circle around them. And what I did, any sign that was in front of that number is part of that term. So once I did that, now I combine the like terms. So anything that was the green, that I circle in green, were put together, the reds put together, and the blues put together. Then I simplified. So simplified, I got negative 4x squared minus 2x plus 3. And what I wrote to the side, standard form, because it's going in descending order. If you look at the variables, notice that the degree for each of them, this is 2, this is 1 for the red one, and there's no variable, so it's 0. So 2, 1, 0, descending order, that's the standard form for any polynomials. So if you were to, when it comes to adding or subtracting, and you combine your like terms, if you combine them and do it in the order from greatest to least, then when you simplify, you'll already be in your standard form, and then you will be in your final answer. So make sure when you simplify, have your final polynomial in descending order, because I will be asking you to do it in a standard form. All right, let's go on to the next one, subtracting polynomials. When it comes to subtracting polynomials, you distribute the negative and then combine the like terms. So you add in a step before you combine. So for the second example, we have two polynomials that we're subtracting. And notice that invisible 1 in front of the second polynomial. So I put it in orange, so that way you know that there's an invisible 1, and that is negative 1, and then you distribute to each term inside the parentheses. So once you do that, you simplify, and then combine like terms. So what I did, so that way I don't miss out on anything that I have to combine, I either circled anything in red that's the same, the blues, the greens. Once I have every term marked, then I can combine. And notice that I combine it based on the degree. So n to the third, the degree is 3, n to the second, the degree is 2, and n to the first, the degree is 1, and I did it in descending order. So once I did that, then, oops, I'm blocking the answer, then I simplify, and then I get my standard form simplified polynomial of 9n to the third plus 3n to the second minus 2 to the n. Alright, so again, when it comes to subtracting, you distribute the negative first, then you combine the like terms. And I know that mistakes will always happen because that poor negative 1 gets ignored and not distributed. So you might end up with a situation where you have negative 7n and positive 4 to the n third, not even distributing that negative to the second term in that parentheses. So be careful. You already learned distribution, so apply it to this one when you're subtracting polynomials. Right. So for this one, we have Sarai and Wendy. They're finding out they find out what the two polynomials, when subtracted, what will it be? We want to know who's going to be correct based on their work. So let's look at Sarai's work. So she brought down the first polynomial, and then let's see, she took there was a negative there, it was being subtracted, but then she had a positive. Let's see, so she distributed, so again I got negative 2a, but then the 5b is still positive, so she forgot to distribute that, but then she combined her like terms and then ended up with 3a minus b. The negative 6b plus 5b gives you negative 1b. Alright, so she forgot to distribute the second term, and she ended up with the second part of her answer of the binomial incorrect. Let's look at Wendy's work. Okay, she distributed, so it came negative 2a and a negative 5b, and then she combined the like terms, so 5a, negative 2a minus 2a, 3a, and then negative 6b plus negative 5b, negative 11b. So Wendy is correct because she distributed. So basically, when she distributed, both of the terms became negative. But whereas Sarai, she did distribute the first one, but she forgot to do 5b, and we're stuck with that plus, and then we ended up with the wrong coefficient in front of b. Right, so again, it's important to distribute when you are subtracting polynomials. Right, so let's look at an example dealing with trying to find the perimeter based on expressions that they give you. Again, you're using polynomials and you're adding them up in order to find out what the result is. Okay, so I'm going to make this bigger. So it says the measure of two sides of a triangle are given. If P is the perimeter, which is 7x plus 3y, find the measure of the third side. So they gave us side C, x minus 2y, and then side B, 2x plus 3y. We're looking for side A. Alright, so you know what perimeter is. Perimeter means you're adding up all the sides. Whatever shape it is, you're adding up all the outer part, which is the sides. So you would write your formula, a plus b plus c equals p. Again, if you had other letters with this one, then you could use any other letters or whatever setup. But again, you're looking for that missing side a. So a plus b plus c equals p, which represents the perimeter. Once you have that set up, then you plug in all the information. So a we're looking for, b is 2x plus 3y, and then c is x minus 2y, and the perimeter is 7x plus 3y. Alright, you got everything set up. Now it's time to combine like terms and do the property of equality so we can solve for a. So notice how I have the red underneath the 2x and the red underneath the x because they have the same variable. Those are like terms. I'm going to combine those two. And the orange underneath the 3y and the negative 2y are like terms, so I'm going to combine those two also. So whatever I underline in red, I turned it into red. They're being combined, and the same with the orange. Combine them, and they turned orange. And I'm going to simplify on that side first. So before I move anything to the other side, I have to simplify any like terms. So I simplify, it came 3x, and then this became y. And now I can move my terms to the other side. So I moved the 3x to the other side. And then this gave me 4x plus 3y on the right side. And on the left side, I'm left with a and y. Y, I'm going to move it by subtracting. And then that will leave me with a equals 4x plus 2y. And that's it. You can't combine them because they both have different variables. So that's the answer for the third side in that triangle. So a equals 4x plus 2y. Again, so you're just applying everything you know about perimeter, about adding polynomials, combining like terms, moving it to the other side to solve for a variable. So everything that you learned before, you're just applying it to this type of word problem. Okay. Let's see. All right, so this one, again, is nothing new because this relates back to what you did in the last unit dealing with substitution, not substitution, systems. So you have two equations. They want you to find AB. All right, so again, doing systems, what would you choose? Would you choose elimination or would you use substitution? Doing systems, would you use substitution or use elimination? So again, you look at what they give you, and means plus, so you're going to be adding those two polynomials, well, the two equations, and I would use elimination because I noticed that if I want to solve for AB, I need to eliminate A and B. But notice that when I multiplied -1 to one of them, both A and B becomes A squared and B squared becomes opposite of each other. So now I can cancel both of them at the same time, and then make sure I distributed the -1 to each term, and then I add them. So then for AB, I got 1AB because -2 plus 3 gives me 1AB, and 36 minus 22 gives me 14. And that's it. I solved for AB. That's what they wanted me to find, and I found it to be 14. So again, going back to your last unit when you were dealing with systems, you're just applying that and using it with polynomials to find missing variable or variables. Right. So this is the end of that. Let's do a recap. We learned about adding and subtracting polynomials. When it comes to adding polynomials, you combine the like terms. That means if there's the same base with the same exponent, you combine them. If you had the same base but different exponents, then you can't combine them. It has to be exactly the same. And once you, when you simplify them and get to your final answer, your final simplified answer, make sure that you have it in standard form. That means descending order based on the variable. So the highest degree goes first, the lowest degree goes last. And when it comes to subtracting polynomials, you need to distribute the negative first, then combine the like terms, and then get your simplified answer in standard form. Okay. Let's see, anything else? And again, you apply the same thing when you're doing word problems, trying to find the perimeter. Make sure you figure out what they gave you and what you need to look for, and then set it up accordingly, and then solve. Same thing like we did with this one, but again, we used systems. That shouldn't be new to you. But again, we're dealing with polynomials or equations and then trying to solve for a term. Right. If you have any questions with this topic, with adding and subtracting polynomials, you know that you can email me. All right, so this ends our lesson, and have a good day.